Good afternoon, my name is John Oliver. These are my teammates Christian Abschi, Chris Hampton, Chandler Lowe, Jonathan Rodriguez, and Tyler Watton. We've been sponsored by TI to make improvements upon their wafer handlers. TI manufactures millions of silicon integrated circuits every day, and these need to be electronically tested on probers. Up here you can see a model of what the prober looks like. And so we've come up with 3 tasks to implement onto the prober that will aid in this testing process. Our first task is to automate a clean dry air system, which is already incorporated in TI facilities. And what this will do is it will allow for high voltage testing. Our second task is to monitor the profiler. What the profiler does is it's supplied air pressure and it descends and takes a couple measurements which determine the thickness of the wafer. And so what we want to do is we want to monitor the speed of the drop. An error that we're trying to fix is sometimes it'll descend too slowly or it won't descend all the way, and this will give a false reading and output a wrong wafer thickness. Our third task is to monitor the burnishing paper. And what the burnishing paper is it cleans the prober needles that test the individual wafer chips. And so what our goal is to be able to output what type of paper's in the machine, as well as the degree of wear on the paper. The current process at TI right now is strictly manual. They hang a placard that tells the technician what type of paper's in the machine, and then they check the specs to see if that's the paper they need, and if not, they change it, but that depicts whether, it highly depends on whether the placard's right, and there's no manual or no automated way of knowing the wear of the paper. So for our CDA system, it's being covered by Jonathan and Christian, and their goal is to use a solenoid valve to control the airflow and a pressure switch that will validate whether 85 psi is running through the prober. And this is important for high voltage testing. The profiler monitoring is being covered by Tyler and myself, and our goal is to have a sensor that will take PSI measurements and compare it to set boundary conditions. So for example, this graph here, and what we want to happen is if at any point in time it falls outside of a certain deviation, it'll output an error, and this will tell the technician that it didn't descend all the way and it's a wrong wafer thickness, and that they need to retest the wafer and also check the profiler for damages. The third task covered by Chris and Chandler is the burnishing paper. And their goal is to have a camera that's programmed to detect what type of paper it is by the color and also monitor the wear. And this will continuously output to an LCD screen so the technician can come by and he can look and see that's definitely what type of paper is in the machine, and it matches the specs, so I don't need to change it. Or they can see it has 70% wear on it, so it's almost close to time to replace the paper. And once we've completed these tasks and test them on the prober, we're going to implement them to a master controller that will be triggered by a graphical user interface. And our ultimate goal is just to make the technicians work easier. Are there any questions?
I think your ultimate goal is to save money and make more chips, right? That's kind of where I was going with this thing. Is you guys have explained it, but I think aren't you really your top level goal is, look, we want to increase the chip yield, and here's 3 areas that we've got that we think we can work on that'll help us increase the chip yield, because all this stuff's being done manually now. But I mean, I think you explained what you're trying to do.
What kind of prototypes have you done at this point? I'm not getting a clear read on anything other than just the kind of the back of the napkin style.
Currently, the equipment is quite large and heavy, and it took a lot of paperwork. So we just got it about 2 weeks ago. So we haven't tested anything on the prober yet, but we've currently got a sensor that will read levels of pressure, and we've got, do you want to tell them about the paper?
Yeah, so on the burnishing paper side, and by the way, for cost, the burnishing paper is quite expensive depending on the media used. It can be up to like $100 a sheet. Wow. So cost is important. So on the burnishing side, we have two big problems: identify what it is and the wear. So we're 99.9% done with the color detection, and we'll demonstrate that later. But we also use Raspberry Pi and OpenCV to do to do the color detection.
So what, you're just measuring the color of the paper as a way of
Yeah,
determining
we're
what it is?
taking advantage of the fact that each of these papers are different colors. The different media is one of the characteristics is they're different colors. So we're taking advantage of that fact.
You know, one thing you guys may talk about is if you get if you get one that's bad, how much does that cost TI? You know, or if you can increase, you know, they always do that. Well, if I can just increase it 1%, we'll make this much. You know, just some kind of a scaled out economics of it.
Sounds good.
All right.
Thank you.